Alright, now that we know pretty much exactly what a vector is, something that has magnitude and direction, let's talk a little bit more about what exactly constitutes, or rather when two vectors are equal, or the equality of vectors. So let's do this with a basic example, alright? Say that we have two roads, alright? Two roads, alright? Now think of you looking above the road, alright? We have a car here. That's a car. That's a car. Say it's going in this direction, okay? And let's say that the car has a speed, alright? A speed of 100 meters per second. Alright, so let's say its velocity is 100 meters per second. Let's say we have another car. Say that it's going in that direction and its speed is also 100 meters per second. Alright, so let's say 200 meters per second. Let's say we have a third car here. Alright, and let's say it's going at 50 meters per second. So that's velocity 3 going at 50 meters per second. Say we have a car here now. Say it's going this way at 100 meters per second. Alright, so let's say velocity 4, 100 meters per second. Say we have another car here going at 50 meters per second. Velocity 5, let's say that's going at 50 meters per second. So we have this little example of a bunch of cars moving on a road. Alright, so by just looking at this, it's obvious to see that car number 1 and car number 2 are going in the same direction and they have the same speed. And what did we say velocity was? It's speed with a direction. So we can say that two vectors are equal if both their magnitudes and their direction is the same. So we can say that velocity 1 is equal to velocity 2. And it so happens that both their speeds are equal, and their speeds will always be equal if their velocities are equal. You see why? Because velocity is speed plus a direction. Now, what if just speeds were equal? Would that mean that velocities are equal? Let's look at this case. Let's look at car number 1 and car number 4 here. Now, car number 1 is going with the speed of 100 meters per second. Car number 4 is going with the speed of 100 meters per second too. But what's different? Their directions. Their directions are actually opposite. So that means we can say that speed 1 is also equal to speed 4, but velocity 1 is not equal to velocity 4. Why? Simply because their directions are opposite. So from this little example, we can see that a vector is equal, alright? So a vector is equal if it has same magnitude plus same direction. See, this is very important, same direction. Imagine this, even if the vector, the direction was like 0.0000001 degrees off, their velocities would not be equal. So we can see from here that even though car number 1 and car number 3, this is car number 3, are in the same direction, their magnitude is different, so their velocities are not equal, so the vectors are not equal. So basically, I think this is a simple way of understanding how vectors, even though they might have the same magnitude, are not equal if they don't have the same direction. It so happens in this example, let's just learn another thing since we're here. We can see that the magnitudes of car number 1 and car number 4 are equal, right? But their directions are exactly opposite, or they're 180 degrees opposite. You know what, let's not talk about degrees. Let's just say that they're pi radian of the angle between them is pi, right? So what can we say? We can say that velocity 1 is equal to minus velocity 4. Why? Because it's just in the opposite direction. We'll look at this in more detail in the upcoming videos, but this is basically just to understand when a vector is equal to another vector and when a vector isn't.